Hello everyone. Today's video is about interval testing, that is specifically inequalities and domain. Today's video is a bit challenging, and when I say challenging, it does not mean impossible. It's just that you need some practice, okay? It is not the easiest part, and again, they will ask you this thing on your MCQ part for sure. We're going to go through two examples, which is the main thing. There is not a lot of theory, but we need to practice the examples. So let's go ahead without wasting time. Okay, I'm going to very quickly go through what is the domain. So the domain of a function f of x is the largest set of numbers x for which f of x is a real number. For example, x plus 4 by x minus 3. You know that when the denominator becomes 0, the function is not defined, and hence for this polynomial, the function will not be defined when x takes the value of 3. So the domain of this function would be all real numbers except 3. I think that was quite simple and straightforward. Let's move to the main part. Let us begin with the main part. It says find all solutions for 3x upon x plus 2 greater than or equal to 2. Now, this is mostly how it will appear on your test. They'll ask you to find the solution intervals for the given inequality. Now, whenever you have anything like this, the first step, okay, the step 1 would be to bring the inequality in the form of f of x upon g of x greater than or equal to 0, which means your RHS should be 0, or at least one of either RHS or LHS should be 0. Now to do that, I'm going to write what I have. We have 3x by x plus 2 greater than or equal to 2. In order to make the RHS 0, which is the right hand side, I'll subtract 2 from both ends. I'll have 3x by x plus 2 minus 2 greater than or equal to, since we have 2 minus 2, that is 0. Now if I take the LCM, I have 3x by x plus 2 minus 2 times x plus 2 upon x plus 2 greater than or equal to 0. I'll make a partition. We now have 3x. Now the 2x goes in and we have a negative sign, negative 2x minus 4 upon x plus 2 greater than or equal to 0. Now 3x minus 2x becomes an x. We have x minus 4 upon x plus 2 is greater than or equal to 0. You see how simplified it has now become for us to be able to analyze what happens to it and when does it become undefined. This is what we have as of now, the most simplified form. We have x minus 4 upon x plus 2, which is greater than or equal to 0. Now your step 2 would be to work with the critical values. Now what is a critical value, you may ask? For now, concerning your AP Precalculus course, a critical value is where anything turns to 0. Just look at where a numerator or denominator could turn to 0. In this case, we have critical points as x equal to minus 2, since when x is minus 2, the denominator tends to 0. And we also have a critical value at x equal to 4, since the numerator turns to 0. There is nothing else in the function, so these are the two critical values that we have. Now, what I want you to do is that whenever you're solving these kinds of questions, I want you to make a line, a number line that we learned in yellow grades. Make a number line, plot your critical points. You don't need to do it to scale, just make them so you can visualize it. And you have 3 sections now. One is x less than negative 2, one is x between negative 2 and 4, and one is x greater than 4. Now, what I want you to realize is that when you're testing for x is less than -2, you do not need to go on testing for -3, -4, -5, -10, -100. You are just concerned with the sign of the negative or positive term. For instance, if you look at what we have, if you look at x is equal to -3, which lies in this range, less than -2, we have -3 minus -4 upon -3 plus 2. If you look at this, we have a -7 upon -1, which turns out to be positive, which is greater than 0. Now, whatever x value you put in, which is less than -2, you will always get a positive answer. So once you test one value, I want you to put the sign that appears. In this case, we have a positive sign. So give it a positive sign. Now we'll test for between -2 and 4 and use the most convenient values. Over here, I'll use x equal to 1. When I have x as 1, I have 1 minus 4 upon 1 plus 2, which is -3 by 3, which is negative, which is less than 0. So we'll write a negative sign up here. Now the last interval is x greater than 4. I'll be taking x as 5 in this case. So when we have x as 5, I have 5 minus 4 upon 5 plus 2, which is 1 over 7, which is indeed positive or greater than 0. I'll have a positive sign here. Now, what are you looking for? We're looking for this. We're looking for the polynomial function being greater than 0 or for the polynomial function to be positive. We are looking for positive. And you'll notice that the output is positive when you have x less than -2 and greater than 4. The last step is to write the solution interval. And while you write the solution interval, I want you to be aware of a few things. So the solution interval. Now, while denoting the interval, if you have a closed bracket or a curved bracket, it means that you do not include the number which is just beside it. When you have a square bracket, you include the number. For instance, in this, we have, I'm going to keep a curved bracket because I do not include negative infinity. It is by convention that you do not include infinity, comma, -2. Now, look, if I want to include -2 in this interval, it is not allowed. If I put x as -2, I get an undefined function. So instead of having a square bracket, I'll put a curved bracket, which means that I do not include -2 in my solution. Rather, it's from negative infinity to -2, not including it. When I make this U, it's a union where I say that it is this interval and the following interval. And over here, I'm going to start with 4 to infinity. And if I put 4, I have 0 upon 6, which is 0. And if you notice carefully, we have a greater than equal to. Okay, we have a greater than and equal to as well. In some tests, you might not have the equal to sign. In some, you may have it. When you have it, you have to keep the square interval, meaning that you also include 4 in your solution while moving to positive infinity. And when you write infinity, it is by convention that you do not include infinity as such. You go to infinity numbers, but you do not include infinity. So this is how you write your solution interval: curve bracket negative infinity, comma -2, curve bracket close, you do not include -2, union, a square bracket, which means you include 4 as your solution, comma infinity, curve bracket close. Now I have with me the second question, which is quite similar to the first one. it says find the solution intervals for phi upon x minus 3 less than equal to 2 by x. Now, I really want you to solve this on your own. Follow the steps that I mentioned in the previous example and solve it on your own. Over here, I won't be going through it in detail. Rather, I'll go through the main steps. Remember, the first step I told you was to bring a 0 on either the RHS or the LHS. So the first step would be to get a phi by x minus 3 minus 2 by x less than equal to 0. And I'll directly simplify it to 3x plus 6 upon x into x minus 3 less than equal to 0. I hope that'll be easy enough for you. Now, once you're done with that, we have quite a few critical values this time. We have critical values at x equal to 3, as you can see. We have a critical value at x equal to 0. We have a critical value at x equal to negative 2. And that's it. For both of these, the denominator turns 0, and for this, the numerator turns 0. And these are the critical values we work on. And again, as I mentioned, you make a number line. You get positive infinity on one end, negative infinity here. I've got a negative 2, I've got a 0, I've got a 3. Okay, negative 2, 0, 3. Now, you'll test for negative 3 here, you'll test for negative 1 for this interval, negative 3 here, negative 1, or maybe a 1, or yeah, negative 1 would be the best here. You test for 1 here, you test for 4 here. And I'm directly writing down what we get. We get a negative here, then I think we get a positive here. We again get a negative here, and for greater than 3, we get a positive again. Yeah, that should be it. Negative, positive, negative, positive. That's how you'll have the domain. And then again, while writing the solution intervals, what you want is a negative sign this time. You do not need a positive sign. If you had moved this guy to the other end over here, you would be looking for positive values, but in this case, you're looking for negative values. So we have a negative value here, and we have a negative value here. So my solution interval would be from negative infinity to negative 2. And you include negative 2. So I will have a square bracket where I include it. You put the union symbol. Again, we have 0, 3, and I have put curved brackets around both of them because for both 0 and 3, the denominator turns out to be 0, which is an undefined function. The reason why I kept a closed interval in the case of negative 2 is that the numerator tends to 0 and we get a value of 0, which is still the case that we require. And this will be your solutions. If you have any doubts about how I got to any of these, you can always reach me out in the comment section. I'll reply to you as soon as I can. I think that should be it for this session. If you face any challenges or if you need any help, let me know. I'll be there. We'll meet soon. Thank you. Have a good day ahead.